Hello and welcome back for another episode of Sip and Learn. So today I'm back with one of the interesting thing which is Azure Traffic Manager. And before getting into this, let's first understand what the endpoint is. So for any application to work, there has to be an associated endpoint, which means whenever user sends a request, endpoint is the first thing which gets hit, right? So if I say in simple term, endpoint is an internet facing service which could be hosted either in Microsoft Azure or it could be outside Azure. So having said that, let's have a quick overview of what the Azure Traffic Manager is and what it does. So as its name suggests, it manages the traffic. So it distributes the traffic across various Azure regions along with the health monitoring capabilities. So if you are planning for a multi-region support with high availability, it could be a perfect service for you. And now you must be thinking, what is the core which is making this thing happen, right? So actually it is the DNS which routes the traffic to endpoints based on the selected traffic manager profile and the configured routing mechanisms. So I will shortly talk about what all routing methods are available. But before that, let's have a quick look at some of the major benefits which we can achieve using Traffic Manager. So the first and the foremost is the high availability. Traffic Manager provides automatic failover whenever endpoint goes down. So it keeps monitoring the endpoints and based on that, it selects the available one. Second comes as the no downtime during the maintenance. So whenever we are planning for any, or let's say whenever there is a planned maintenance activity, traffic manager redirects the traffic to other endpoints, so which are configured. So we need not to worry about what would be our downtime windows and how much duration will it be taking. Everything will be very smooth when we are going with the Azure Traffic Manager. Another comes is the responsiveness. So Traffic Manager has the ability to perform calculation in order to know which endpoint will provide the lowest latency to the user, right? So in a way, Traffic Manager improves the responsiveness by redirecting the traffic to such endpoints which are very closer to the region where user is sending the request. And another capability of Traffic Manager, it not only supports Azure endpoints, but it also go hand in hand with other external non-Azure endpoints. And last one, it allows to combine multiple routing methods to achieve any complex scenario. So we need not to stick to one particular routing method. We can combine them, we can use nested mechanism, and we can make our things work. Now, these are the available routing mechanism as of now with Azure Traffic Manager. So first one is the priority. So as its name suggests, it works on the basis of how the priority is assigned. So whichever the endpoint is having the higher priority, traffic would be redirected to that one. And by any chance, if endpoint having highest priority is down or it went unhealthy, in that case, request will automatically be redirected to the next available second highest priority endpoint, and it keeps going on like that. So such routing method is very useful when we are particularly working in the disaster recovery scenarios. Performance. So coming to the performance, it depends when endpoints are configured in different geographic location and we want to select the one which is very closest, right? So whenever we are expecting the very lowest network latency, there comes the performance mechanism. Third one is the geographical. So this method route users based on the geolocation, or say it works based on the geography the DNS query originates from, right? So it totally depends from where DNS query is coming. So it may look similar to performance, but actually it's slightly different. So the best use case I can tell you over here is, let's say due to some compliance or government regulations, we want all our traffic to redirect it to East US. Now in that case, geographical mechanism can be used. So, and how it works is totally depend on the way we are selecting or we are creating our geo-based profiles. So we can choose the profile and make the things work. Next is the weighted one. So in this particular mechanism, the endpoints have the designated weights, and that ranges from something between 1 to 1000, and based on the weight, traffic is accordingly redirected. Multi-value. So in this method, for a single client request, there could be multiple endpoints available. But the one caveat here is one cannot go with the server name mapping. It has to mandatorily go with IPv4 or IPv6 addressing. So unfortunately, I couldn't find the use case for this one, so would not be able to tell much about it. Next and the last is the subnet. So this could be one of the very useful mechanism when we want to restrict some of the traffic, because it works on the basis of the range. So we can provide the IP address range which should hit the particular endpoint. So let's say you want address from 1 to 100, in that, and 1 to 100 should go only to West US endpoint, and rest all should go to the respective geolocations. So that thing can be easily handled using the subnet category. So with that, I think well enough of theory, and let's have a look at the practical example of how we can use the priority based routing. Okay, so this is my Azure portal, and I have already created two instances of my web application, and both of these applications you can see are in different geolocation. So one is in West US, one is in Central US. So I haven't done anything fancy in these web applications, and I'm just using the default page, and the same thing we will be showing when we are verifying our traffic manager settings. Okay, let's go to home page and we'll create one traffic manager profile. So this is the traffic manager profile. Create profile, and we can give some name over here. Let's say channel group traffic manager, and this demo we will be particularly going with the priority based, but in next one we can definitely try these ones. So priority subscription I have selected. I have already created a resource group, which is this one, and click on create. It may take few seconds. Oh good, it's done. Now go to resource, and it should show up over here. Okay, now next thing is go to endpoints, and under endpoints there is an add button, so click on that. I will stick with this Azure endpoint because we are going to add an endpoint, and let's give some name, channel let's say endpoint 1. Okay, and here I am selecting app service because I have deployed both the web apps as a web service. Target, so this is the application I am taking. So let's say West US. So this is the application which is deployed under West US, and I'm assigning priority as 1. So custom header settings, we can leave it empty. It's not mandatory criteria for a demo. Let's give a few seconds and it should be up. Okay, so this one is created. Let's go and create another endpoint, and I will name it channel endpoint 2. Again, we can go with app service. This time I will select the one which is in Central US region, and I'm assigning priority as a 2. Okay, so both the profiles are created, and in a while you will say that these are up and running. So meanwhile, let's go to overview, and you will notice that DNS name is generated, and it is something like channel group traffic manager.net. Let's go and try to navigate to that. So you can see that the web app is up and running, right? So this is default page which I was talking about, and right now it is coming from the endpoint 1 because I have assigned the priority as 1. Okay, next what we will be doing is we will be disabling this priority 1 endpoint, and we want our site to run on the priority 2. So for that, let's go back to app service, and I will go with that. And what I will be doing is I will simply, right now you can see it is running, so I will stop it. Okay, so now it is stopped. Go back to Traffic Manager, Traffic Manager profiles, channel group. Okay, so here also we can see that monitoring status is stopped. It means if I am again navigating to this my application, it will be serving from this endpoint, which is channel endpoint 2. So let's go and try to see if it works. Cool. So you can see that app service is still up and running. Right. So now this time it is serving from the endpoint 2, which is having the priority. So this is how we can deal with this. And if you want to check whether it is really considering these endpoints, so for that we can just do a quick round of test, and this time I will disable this app also, which is in central US. Stopped. Now if I will go back to my traffic manager, and I can see both are stopped, right? In this case, see, app is stopped and nothing is running. It means earlier when it was running, it was serving from either of these two endpoints, right? So this is how we can manage based on the priority. And that's all I have for today. So see you next time with another type of traffic manager method. Till then, keep sipping and hope you enjoyed this video. Thank you.